an electron projected perpendicular to a uniform magnetic field B moves in a circle. If Bohr's quantization is applicable, then the radius of the electronic orbit in the first excited state is. So B is the applied magnetic field in the perpendicular direction. Then we have to find the radius of the orbit. Now the electron is moving in a perpendicular direction to the applied magnetic field. That's why it is moving in a circular path. Now if the r is the radius of the circular path, then the centripetal force mv square by r is equal to qv cross b. qv sin 90, sin 90 is 1 and v is the velocity. Then 1v cancels, that is mv is equal to qbr. So this is the relation, mv is equal to qbr. And here if Bohr's quantization is applicable, now Bohr's quantization rule is the angular momentum mvr is equal to nh by 2 pi. So here we have to calculate the radius in the first excited state. So first excited state, that is n is equal to 2. For the ground state n equal to 1, first excited state n is equal to 2. And mv is qbr. So put the value of mv, that is qbr into r, that is r square, is equal to n is 2, that is 2h divided by 2 pi. So 2 cancels. So r square is equal to h divided by pi q b, or r is equal to root over h divided by pi. Now q is the charge of the electron, that is e, pi e, and b is the magnetic field, that is root over h by pi e b. So option 4 is the correct answer. Thanks for watching. Please like this video, subscribe my channel and share this video. Thanks.